Alright, so here we are in part 2, and given the same function g of x and the same function f of x, where there's a sharp turn at 2 for f of x, I want you to find h prime of 1, h prime of 2, and h prime of 3 if h of x now is g of f of x. So this means that h prime of x is g prime of f of x times f prime of x. So I want you to pause the video, find h prime of 1, h prime of 2, and h prime of 3 if they exist. Unpause when you're ready to check your work. Okay, so h prime of 1 is g prime of f of 1 times f prime of 1. F of 1 is 2. That's right here. F prime of 1 is also 2 because the slope at 1 is a slope of 2. So g prime of 2 is negative 1, so I have negative 1 times 2, which is negative 2. So that's h prime of 1. H prime of 2 is g prime of f of 2 times f prime of 2. F of 2 is 4. So this becomes g prime of 4, but f prime of 2 does not exist. So it doesn't matter that g prime of 4 is also does not exist, because f prime of 2 does not exist. So therefore h prime of 2 does not exist. H prime of 3 is g prime of f of 3 times f prime of 3. F prime of 3 is right here, which is a slope of negative 2, so f prime of 3 is negative 2. F of 3 has a value of 2, so it's g prime of 2, which is negative 1, so I have negative 1 times negative 2, which is positive 2. Alright, last one. Same graph, but now h of x is f of x. So that means h prime of x is f prime of f of x times f prime of x. So I want you to evaluate h prime of 1, h prime of 2, and h prime of 3. Pause the video, unpause when you're ready to check your work. Alright, so here hopefully you got that all three of these do not exist. So let's look at why that is though. H prime of 1 is f prime of f of 1 times f prime of 1. F prime of 1 is the slope at 1, which is 2. F of 1 is also 2. So this part is f prime of 2, but f prime of 2 does not exist because that's our sharp turn. Therefore, h prime of 1 does not exist. H prime of 2 is f prime of f of 2 times f prime of 2. F of 2 is 4, so this becomes f prime of 4, but f prime of 2 does not exist, so this does not exist. H prime of 3 is f prime of f of 3 times f prime of 3. F prime of 3 is right here, that is a slope of negative 2. F of 3 is 2, so this becomes f prime of 2, which we know does not exist. Okay, so the chain rule is very important. It's useful in the derivative, or finding the derivative of the composition of function, and when we combine that with the product rule and the quotient rule, we can take the derivative of most functions. That's the end.